I'm looking at question 4. Again, this question relates your speed of light equation and your Planck's energy equation. And so I'm going to look at my data. My data here is that I have the wavelength, and so my wavelength is 4.06 times 10 to the negative 11 meters, and I'm being asked to calculate the energy of this light. And so this particular light has this particular wavelength. It's 4.06 times 10 to the negative meters. I want to now look at what is the energy. So remember, energy can only be calculated in our case right now using Planck's energy equation. And Planck's constant is always a constant. Remember that that's 6.63 times 10 to the negative 34 joule seconds. Frequency is something that I can solve for. But I'm not looking for Planck's constant. That's a constant. I don't have frequency. I'm looking for energy, but the only variable that I have right now is this variable right here. I just have my wavelength. So I need to figure out how to go from my wavelength and solve for my frequency to then plug that into my other equation. I need to figure out how to tie the two equations together. So to begin with, I'm going to use my speed of light equation, and I know that I have my wavelength, so I'm going to go ahead and isolate that to solve for my frequency. The reason why I'm doing that is because speed of light is a constant as well. It's always 3.00 times 10 to the 8th meters per second. So when I'm solving for frequency, that means that I'm going to end up saying speed of light divided by wavelength. Again, speed of light is a constant, and we're using 3.00 times 10 to the 8th meters per second. I'm going to divide by the wavelength provided to me. So 4.06 times 10 to the negative 11 meters. Hopefully you can see meters in the numerator, meters in the denominator. You are left with seconds in the denominator. This is now where you need to recall seconds in the denominator means s to negative 1. Seconds in the denominator means 1 over s. You also remember that frequency hertz is 1 over seconds, which is the same as s to the negative 1. And then keep in mind that we said this is what we're sticking to, s to the negative 1, 1 over s for our units in the calculations. So now I can go to my calculator, and I just have to remember to put in parentheses. So I'm going to do open parentheses, 3 times 10 to the 8th, close parentheses, and I'm going to divide that by open parentheses, 4.06 times 10 to the negative 11, close parentheses. So my calculation answer is 7.389162562 times 10 to the 18th. This is just my calculation answer, and remember this is s to the negative 1 units, or 1 over s. So now that I have calculated my frequency, I can now take that frequency and I can put it into my energy equation. So E equals h times frequency. H is my constant, it's Planck's constant, 6.63 times 10 to the negative 34 joules times seconds. My frequency that I got, I'm not doing any sig figs. I'm taking this straight and just putting it right in here. So 7.389162562 times 10 to the 18th, s to the negative 1. Hopefully you still have that number in your calculator. You didn't clear it. So now all you have to do is multiply it by Planck's constant. Just remember to use open parentheses. So take your frequency, this number that you have in the calculator, and just say times open parentheses 6.63 times 10 to the negative 34. And so your calculator now tells you 4.8990147 times 10 to the negative 15th. So now the last thing I need to do is I need to make sure that I'm okay with my units. So when I go to my units, I have seconds, and then seconds to the negative 1. Those are reciprocals of each other. They cancel each other out. I'm just left with joules. So this is my unit. My very last step now is sig figs. I'm finally ready. And so the only piece of data that I had in my question is that right here. Everything else was a constant. So those are infinitely significant. Those are exact numbers. And so 4.06, that's 3 sig figs. 1, 2, 3. The number behind it bumps it up. And so my final answer is going to end up being 4.90 times 10 to the negative 15th joules. And that's my final answer.